Okay, hello students. In this lecture, we are going to learn about prism and refraction through prism. What is a prism? Prism is basically, if you look at it, it is a three-dimensional object, okay, with five plane surfaces. If I draw, suppose if I draw three-dimensional, it will be like it. So it will be a three-dimensional triangular shape object, okay, which has basically three surfaces, base you can say, okay, and two plane covering front and the backward, okay, two triangular face you can say. This is my triangular face, this is my triangular face, okay, and the rest one is what, rectangular, or you can say parallelogram type form, okay, this rectangular or this one, right? So we have a prism is basically what, a three-dimensional shape which has two triangular faces and three rectangular faces. So we have two rectangular faces, and if you just join this, you will get three rectangular faces, okay. This is my prism. Now for sake of study, what we will show only the one face, triangular face of the prism, okay. This is called as my base. We will always keep our prism like this, and then we will study about the refraction. So understand the prism first, okay. Okay, now let us understand how refraction happens in prism. Okay, I have drawn this prism. Let us see, this angle is what? A. This angle is A. This is known as my prism angle. Okay. Okay. Normally, so what will happen? Let us say a ray, an incident ray, which is just coming in this direction. Okay, strikes the one surface. Suppose at this angle, let's draw one normal also. This angle is what? I. What will happen? Since this is made up of glass, okay, so what will happen? The ray will bend towards the normal. Let us see, this is R1, okay. Again, if you draw a normal at this place, take this angle as R2, and what will happen? It will E. Okay. So what has happened? A ray which strikes one surface at an angle I, and it faces two refraction. Okay. First at this point it will bend towards the normal, and then again strikes the next surface, and again it will bend away from the normal in this direction, right? So what has happened? A ray which was going in this direction has moved to this direction. If you just check what has happened, it was going in this direction, but now it is going in this direction. So this angle, the original direction and the new direction, this angle is known as my angle of deviation. Correct? This angle is known as my angle of deviation. Now we will find out the formula for this angle in terms of prism angle, angle I, and F. Let us see what else is there. So now if you look at this, what is this angle? I, and let us say this, join this. O. Correct? This is my suppose point B, and this is my point C. Okay. Now, if you look at the quadrilateral A, B, O, C, this quadrilateral, right? This angle ABO, you can write in quadrilateral ABOC, angle ABO is equal to what? Since this is my normal, so you can say it is 90 degree. Similar thing we can say about this angle, angle C, which is angle ACO. Angle ABO and angle ACO, both are what? Perpendicular and equal to what? 90 degree, right? So in a quadrilateral, if you look at all the angles, sum of angle is what? 360. So what is the remaining angle our? Angle A and angle O. So we can write that angle A plus angle O is what? 90 plus 90, 180. So what is left? Remember this relationship. That angle A plus angle O is equal to what? 180 degree. Why? Because we have just shown that in this quadrilateral these two angles are 90, 90. So 180, and sum of all angles is what? 360. So we have sum of angle A plus angle O as 180. Correct? Now next, if you look at this angle and this angle, correct? What is this angle? See the whole angle. If you look at this dotted line I have made, the whole angle is I, because vertically opposite angle. So the smaller part, this is what? I minus R1. Correct? And what is this? This is I minus, or you can say E minus R2. Same logic. Here also the whole part was E, the whole part is I. So what is left out? E minus R2 and I minus R1. If you look at this triangle, let us name it this M. Okay. Let us look at this triangle BMC. In triangle BMC, this angle of deviation is basically what? My exterior angle. So delta, we can write it as, and we know that one property, that exterior angle of a triangle is what? Is equal to sum of its opposite interior angles. These two angles are my opposite interior angles, so we can write it like I minus R1 plus E minus R2. Correct? Now look at this triangle, triangle BCO. In triangle BCO, we can write R1 plus R2 plus angle O. R1 plus R2 plus angle O is equal to what? 180 degree. So we can write R1 plus R2 is what? 180 minus angle O. But we know that 180 minus angle O is what? Angle A. So we have got one relationship, R1 plus R2 as A. Got it? Simple. And in this triangle BCO, we can write R1 plus R2 plus angle O, sum of interior angles of a triangle is what? 180. And we have already proved it that angle O plus angle A is also 180. So if you compare these two, we will get R1 plus R2 as A. Correct? Now let us write this equation again. So my delta is equal to what? I plus E, and if we take minus common, it will be R1 plus R2. So delta is equal to I plus E minus, I am replacing R1 plus R2 as A. So we have got one relationship, delta plus A is equal to I plus E. Correct? So we have got relationship which includes angle of deviation, prism angle, angle of incidence and angle of emergence. Remember this formula, delta is plus A is equal to I plus E. Okay, now we will understand the factors which will decide my angle of deviation. We have just learned the formula for angle of deviation, which is what? I plus E minus A. Let us take down the different factors which will decide the angle of deviation. Okay, so first factor is I, right? Angle of incidence, right? Now let us understand in detail what is the angle of incidence factor which will decide the angle of deviation. Okay, so by different experiments, or you can say by taking different angles of incidence, we have plotted a graph which will contain angle of incidence and angle of deviation, I versus del. Okay, so we have plotted a graph and it has come out like this. Okay, so let us understand this graph, that if we increase our angle of incidence, so initially what will happen, my angle of deviation, which will start from here, this point, it will goes on decreasing. So initially when you increase the angle of incidence, your angle of deviation starts decreasing and it will reach a minimum point. This point we call it as del minimum, right? We will reach a minimum point, and afterwards this, let us say this is the I for which my del is minimum. I minimum doesn't mean the minimum I. I am saying I minimum is what? For I for which the del is minimum. Okay, now if you further increase the angle I, what will happen? The angle of deviation starts increasing and it will keep on increasing. So this point is very important for us, and it has been found out that whenever this happens, at the minimum deviation is there, my I is equal to E for del minimum. For minimum deviation, we have observed that always angle of incidence is equal to angle of emergence. This is all by experiment. There is no mathematical proof for this. So we will say that my del minimum, if we want to derive a formula for this, del minimum is I and E both are equal. Let us say I plus I, so it will be like 2 minus. So we have a formula for minimum deviation, which is what? 2I minus A. Okay, so understand this thing, that for different angle of incidence we have a different angle of deviation. Initially it will decrease if we keep on increasing the angle of incidence, and at one point it will be minimum, and afterwards it will again increase and goes on increasing. Got this one? Now the second factor, of course, angle of emergence. Angle of emergence, you can see now this depends on two things. So I would say A, 2A. 2A is what? The angle of emergence is dependent on refractive index. Refractive index of the prism. Refractive index of prism. Because see, if you look at the diagram, this I, this R will be decided by the refractive index, and this R also, right now. So this whole deviation will depend on refractive index of the prism. So angle of emergence depends on what? Refractive index of prism. Hence the deviation, which is dependent on the angle of emergence, is dependent on refractive index of the prism. Second point for this angle of emergence will also depend on the wavelength of light. For different wavelength we have different angle of emergence. Okay, hence for red light we have a different angle of emergence, for violet we have a different angle of emergence. And if you look at the spectrum here in which vibgyor forms, right, the violet suffers the maximum deviation, however the red suffers the minimum deviation. So for different wavelength we have got different angle of deviation, and hence the wavelength is a deciding factor for angle of deviation. Third one is finally my angle of prism. Correct? So more the angle of prism, less will be the deviation. So these are the factors which will decide the angle of deviation in a prism. Okay, before concluding the prism chapter, prism topic here, let us understand we have studied two types of refraction, one through prism and one through slab. What happened in slab? Incident ray, the refracted ray, and the emergent ray. These two rays were what? Parallel to each other. This was my incident ray, this is my emergent ray. These were parallel to each other. Okay. In case of prism, this was my incident ray, this is my emergent ray. This I and E are not parallel to each other. However, this emergent ray is what? Is bent towards the base. Right? If you draw prism like this, and if you draw incident ray, what will happen? My emergent ray will be like this. So if you want to move your emergent ray downwards, keep the base down. If you want to move emergent ray upward, keep the base upward, because the emergent ray will always move towards base, always, right? If it is moving from, of course, rarer to denser, this is my rarer, this is my denser. If you change the medium, something else will happen. Okay, remember this point.